So now we're going to be looking at systems of linear and quadratic and absolute value inequalities. So still pretty much similar to equations, except for the only method is to graph, and we have to remember a few rules with inequality graphing. So if you can recall, these are the types of inequality systems that we solved before. Linear, so just graphing both lines, and then the solution is where they overlap. And remember, greater than, equal to, less than, equal to tells us a solid line, and whenever we have greater than or less than, it's a dashed line. So those are the big things we have to remember, is where to shade and what type of line I will have, dashed or solid. So here's an example of what a quadratic inequality will look like. So I just have two different parabolas graphed on the same coordinate plane, each shaded in according to the inequality symbol. Notice it's less than or greater than, so we have dashed lines instead of solid lines. And then our solution set is actually going to be in the overlapped region, okay, which in this case would be right here in this graph. Now remember, the solutions do not include any points that lie on the dashed line, because dashed means that it's not equal to there. Alright, so now we're going to graph two quadratic functions on the same coordinate plane, and we're going to look at where these two functions overlap, and that's going to be our solution set. So remember, for inequalities, the only way to solve is by graphing. So whenever you are graphing a parabola, let's just run down and remember, you find the vertex. Once you find the vertex, you pick points close to the vertex, and then you plug those into the function, and you get the y-coordinate. And then we're going to decide dashed or solid, and then we're going to shade. Okay, so the first thing I'm going to do is graph this first function here. So I'm going to find the vertex, so negative b over 2a, negative 4 over 2 times negative 1. So that's 4 over negative 2, which is negative 2. So the x-coordinate of my vertex is negative 2. I'm going to go ahead and plug that back in to find the y-coordinate. Evaluating this, we're going to get negative 4 plus 8 plus 3, which is 7. So the vertex is going to be negative 2, 7 for the first quadratic. So I'm going to go ahead and make a table of values. Since we're at negative 2, 7, I'm going to plug in negative 1. I'm going to plug in 0 to find additional coordinates on my parabola. So going ahead and graphing this, we're going to do negative 2, 7. I know that this parabola should face down because of the negative a. And just because I want to see the shape of the parabola, I'm going to go ahead and plug in an additional point on the graph to see exactly what the function is going to look like. So I'm going to plug in 1 and see what we get. So go ahead and plot my additional point, 1, negative 2. And remember, we have an axis of symmetry of x equals negative 2 where our vertex is. So I'm going to go ahead and reflect all of those points. And because we are less than or equal to, it's going to be a solid line. And since it's less than, we are going to shade below. So I'm going to go ahead and shade below. And that is where my solutions are going to be for that parabola. So I'm going to go ahead and repeat the same thing with this second function here. I'm going to find the vertex. I'm going to plug it in, make a table of values, and then graph. Notice that b is 0. So my x-coordinate of my vertex is going to be 0, and when you plug in 0, you're just going to get 3. So I'm going to pick points close to 0. I'm going to pick 1 and 2. When I plug in 1, I'm going to get 4. When I plug in 2, I'm going to get 4 plus 3, so it's going to be 7. So I'm going to go ahead and plot these points and graph my parabola. So 0, 3. They share that common point. 1, 4. And 2, 7. Anything bigger would go off my graph, so that's the only points I'm going to plot. Going ahead and reflecting them across my AOS, which here is the y-axis. And then now I'm just greater than, so I'm going to be a dashed or dotted line. And we are greater than, so I'm going to shade above. So you can see that our solutions are going to include the points that they have in common, which are these points here, along with the overlapped region, which is this small area between the two parabolas. So remember, they're still graphing, so you still want to go ahead and label your x and y axis, and it would be really great to label the majority, at least 5 of the points on your parabola, including the vertices of each one. And it's helpful for me if you go ahead and label which parabola is which. That way I know when I'm grading which one you are graphing. Alright, so now we're going to look at a system that is a quadratic function and an absolute value function. So I'm going to have a u and I'm going to have a v, and I'm going to look where they overlap. So first, for the quadratic, remember to find the vertex we do negative b over 2a. Here there is no b, so that means it's going to be 0. So when I plug in 0, I get just negative 3. And then I'm going to go ahead and plug in additional points. I'm going to do 1 and 2. So when I plug in 1, I get negative 2. When I plug in 2, I get 4 minus 3, which is 1. I'm going to go ahead and pick another point just so I can see really what it looks like. When I plug in 3, I get 9 minus 3 is 6. So I'm going to go ahead and graph that. 2, 1, 3, 6, 1, 2, 3, 4, 5, 6. My axis of symmetry is actually my y-axis, so I'm going to go ahead and reflect those points over the y-axis. I am greater than, which means I'm going to be a dashed line. And now I am going to go ahead and shade in above, right? Greater than, y greater than. I'm going to only focus on the y-axis. I want to be greater than that, so I'm going to shade everything greater. Alright, and now I'm going to go ahead and graph the absolute value function. The absolute value function is the parent function just shifted up 1. So you can see that the vertex here is just going to be 0, 1. And remember, for absolute value functions, as long as I have nothing in front, and as long as there's nothing in front of the x, that means on both sides it's just a slope of 1. Remember, that's only if there's no stretch or compression. So make sure you check that before you start just graphing. No stretch or compression, it's just a slope of 1 on either side. Now, looking at my inequality, I am less than, so that means I'm going to be a dashed line. And less than means I shade below, so shading everything below the absolute value. Please make sure you extend on your graph. Now, my solution is going to be located where they overlap. Just labeling my vertex and axes here. And this is my parabola. And my V. Now the solution is going to be located where they overlap, and where they overlap is this area right here. So any coordinate that exists on both of those graphs there are going to be solutions to my system of equations. Of inequalities, sorry, systems of inequalities. Alright, so I want you to go ahead and try this system of inequalities. Notice this is going to be a quadratic in a line. So you're going to have a quadratic in a line, and make sure you pay attention to the inequalities to know where you need to do dashed or dotted and where you should shade.